afternoon. We are here to discuss solid principles, and without any delay, let's get started. So, a quick intro about myself. So, I'm a founder of a company called as Smartogram Innovation. Basically, we are developing products which helps agile transformation, particularly in technical transformation area to speed up the transformation. So we are building tools that can complement your practices like TAD, VAD, clean code, refactoring, continuous integration, and deployment. So apart from that, I have craftsmanship coaching experience for last 4 years. I've worked with investment banking and digital marketing domains in the last 4 years as a technical coach. So that's about me. When we get to Q&A, we'll also give a fair chance to the audience to introduce themselves and have a quick chat. So let's get started with today's agenda. Solid principles. Solid principles, when we speak about the foundation, we start with the object-oriented principles or object-oriented design principles. So building on top of object-oriented principles, when we are building any applications, we focus on some of the bare minimum design things that has to be ingrained into the system so that the design is flexible. And as you see on the right-hand side of the slide, it's inside out that the foundation of the core is object-oriented principles, and then we have solid principles, which is embracing those, and the design patterns, which has finally ingrained all the principles or most of the principles that we want to discuss in this webinar series. For today, we are only focusing on single responsibility. Let's explore what a single responsibility principle and what are the benefits, how to identify or get to single responsibilities. Are we already doing it? Where to look for examples, and so on. So, yeah. When we speak about software development, we inadvertently or by all means, we speak about the dependencies or the complexity of building software. Right? When we speak about solid principles, we are actually speaking about solutions for those dependency management. So a simple idea about dependency is that if there is number of dependencies and the dependencies increases, very likely attributes like reusability, flexibility, and maintainability of the code decreases, which will lead to a complex conditions of maintaining the software. And we keep hearing right from a person who has just got his hands on the system to the most experienced person in the organization, telling that, hey, you know what, this is a complex design. This code is coupled. This is tightly coupled. We come up with a magical word called as tightly coupled. So you cannot make changes so easily. You cannot refactor this code so easily because it is tightly coupled. So the main reason behind this is the way dependencies are managed in the system, the complexities that are present in the system. So we are going to see throughout this series how solid principles, being the core of design principles, help in maintaining those dependencies and having better software architecture. Coming to today's main topic, single responsibility principle. So this is a snapshot from a book by Robert C. Martin, which speaks about things that this super Swiss Army knife can do. So if we look at this picture, so it has a knife, it has got a screwdriver, it has got a hedge, it has got whatnot. I can't even name how many tools that this kit has. So when we ask, what is this used for? There is no one clear answer. So it is used for everything, right? So when we speak about responsibility, we are speaking about who does what. When I'm speaking about this tool, I'm not sure what the whole and sole purpose of this tool is. It is all in all. So when we are dealing with multiple responsibilities, we may end up focusing on some and not focusing on some and not doing the best of all things that is available in this. So single responsibility principle states or demands that just do one thing and do that thing really, really good, right? So I was talking to Yasub just before the call, and I was telling Yasub, in day-to-day life, we do embrace single responsibility principles very in every often stage. So I was telling that when we discussed that we have to do a webinar series, there were a couple of volunteers who came and said that I will be responsible for this, booking a slot for this, and gathering people. And the other person said that, hey, I was going to circulate about this. And the responsibilities was divided among people so that not one person could do everything. It doesn't mean that one person was not capable enough to do it, but if it was only one person show, I think it wouldn't have been so organized or uh, the way it is now. So that's about responsibility. The more responsibilities, the difficult to manage, the difficult to handle, and that's what we deal with software. When we are designed or we are finding ways to handle responsibilities in a distributed manner, in a delegated manner, we have to be doing the same with the software that we build. A single piece of software need not be responsible of doing everything. We have to see how responsibilities can be distributed, identified, and given to right pieces of software or classes that can handle the responsibilities in a better manner. So by that, we move on to identify how to identify responsibilities. As I mentioned, responsibility is about how and who does something, right? Or perform something. So when we want to identify responsibilities in a class, in a system, the main area or the main axis that I would say to identify responsibility is what is the reason for change. If we look at a class and see that, okay, this class has got one reason, two reasons, three reasons to change, then there are multiple reasons for the class to change. For example, when we talk about a class like e-cart or e-commerce website, and we are speaking about it contains stock items, it contains offers, it contains promotions. So it has got multiple things. If all things are coded in a single class, then there are multiple responsibilities, there are multiple reasons for change. If there is a change in promotion, this class is going to undergo change. If there is a update in the stock item quantity, unit price, or any of this classes will undergo change. So to identify the responsibilities, we see that what all the axis of change, when requirements change, what all the axis of changes that this class can undergo changes. Based on that, we group or we categorize responsibilities and see that, okay, these are related responsibilities and this should be together. When we are not able to make such decision, we fall back to the basics of object-oriented programming and say that, hey, this data and function has to stay together. So let's see that what has to be encapsulated, what's the right encapsulation, and what is the right abstraction. So we're going to see when to stop, also graining this responsibility in a couple of examples that we discuss as we proceed here. So the key thing is here, yes, responsibilities are axis of changes. If you're asked to identify whether a class is responsible for one thing, you can ask a question that what are the reasons for these classes to change, or take a look at what is there inside the class and question yourself that is this multiple reasons, are there multiple reasons for this class to change. And the moment you see that there are multiple reasons, there are multiple responsibilities, and when there are more responsibilities, it's more likely to change. And when there is more chances of change, then we go back to the same problems, that the software is rigid, it is difficult to make changes, it is tightly coupled because all responsibilities are there together. So just keep in mind that there should be always only one reason for a class to change, and that is driven by the volatility in your domain, volatility requirements, or the changing requirements, demands of the customer, needs of the customer. Right. So have you noticed this in your day-to-day frameworks that you use. I'm going to take an example of .NET Framework here to see on what basis this responsibilities has been separated. A simple example is on database classes that we use. It might be system.data and SQL client classes. The other one might be system.io text writer, text reader classes, right? So these are operations that we need to perform, let's say for database operations, for file operations. Responsibilities here are connecting to the database and querying the database, issuing a command, and so on. So we'll deep dive into the source code of these classes and see how uh, this is separated based on the responsibilities. And we'll discuss how architectural patterns are using this by separating responsibilities. Let's say MVC, we have clear segregation telling that this is a model, this is a view, and this is a controller, and how or each and every layer interacts with each other. Separation of concerns is other concepts where we have adapted responsibility based on what concerns we are dealing with. Is it logging? Is it security? Is it database? Any concern that we are dealing with, we see how we can separate these concerns so that the dependency is reduced or the complexity of the software is brought down. So let's quickly go to the examples. I'll take you to Microsoft website. As you know now, the source code is open source and available. First thing we'll discuss about responsibilities segregated based on operations. We are looking at database uh, related topic or function here. So I've navigated to system, data, and SQL client. Here you can see that couple of common things when we use to connect to any database while we are working with .NET Framework. So here is SQL command, and right behind SQL command, you could see that there is command builder. Right. So let's pause a minute and think about it.
Satish,
Yeah.
are you sharing your other screen?
Okay, is this not visible? Oh, that's you share. I think yes. Thanks, Yasuk. Thanks for intervening. Is it now visible?
Yes.
Great. Awesome. So what I've done is I've gone to reference source so that we have examples let's say that we daily use, the frameworks that we are familiar with. So we can easily connect to that. So this is an example of SQL client, and I have just highlighted SQL command and command builder. Right. So when we see this, so there is a responsibility of building a command and actual execution or usage of that command. So there are two responsibilities. One is building the command itself and execution or usage of that command. It's quite so possible that we put these responsibilities together, but if you see that it's totally different. Construction of or building a command is a totally different responsibility, and execution of command is different responsibility. When I was speaking about access of changes, if this two code was in the same class, then there were two reasons. One is building a command, and the other reason was executing the command. Similarly, we can find a lot of examples in same way. We'll see SQL connection and also explore how SQL connection is using SQL command and builder to achieve the purpose. So here is SQL connection class code. So I'll just quickly find SQL command object in this class, the usage of it. No. So there are 4 here. So validate SQL command. So I'm looking for the constructor, so where I can show you how it is used. Okay, here we go. Just bear with me for a minute. All right, so here we are right at the top of it. So when I initiate SQL connection, I pass in connection string, but internally I make use of SQL connection string class that is just what I showed a while ago by highlighting about the command builder and command itself. Make use of that to parse the connection string and have it. So you also might notice some of the validations are also here, right here, which is related to the connection string. And if we go to the actual connection string class itself, it also has similar validations that is very specific to SQL connection. What I just wanted to demonstrate is that SQL connection makes uses of command in a way that is composed inside the class itself and abstracted from the end user so that the responsibilities are separated, but still whatever behavior that SQL connection has to have is composed with having these classes. Similarly, when we speak about SQL data adapter, you can see that there are multiple commands that a data adapter can issue. One is delete command, other one is insert command, the other one is select, and the last one is update. There are two possibilities here. One, having all this code right inside adapter class, or thinking that, hey, you know what, command is a separate responsibility. Let's move that code to command class and use that command as a composition inside SQL adapter, because SQL adapter depends on SQL command and it needs SQL command to execute queries. So now the code is moved to SQL command and SQL command is consumed or composed within SQL adapter. So we can find a number of examples like this. We'll just see one more example and we'll quickly move on to some of the code examples that we have lined up for you. So you could see here there are text writer classes, text reader classes when we talk about file operations, and there is stream writer and reader operations. So here, based on the operations, the responsibilities are divided as reading a file as one responsibility and writing to file as another responsibility. So, and hence we see that we have two classes that has been divided. Now, when we speak about any architectural pattern that I mentioned, how responsibilities have been divided, either between layers or as layered architecture. So I just show you one of the example from Microsoft MVC, and let's continue this discussion. I have just created a student's controller, right, which has got all the HTTP verbs or the scaffolded code that you could see here. There is get, which is read. There is post, which is edit or update, and then we have a delete, a post with delete, which is actually deleting a resource, right? So now we were speaking about operations as responsibility, but here we see that there is read, there is create, there is update, and there is delete. What happened here? Did Microsoft miss on segregating responsibilities, or have they done right thing? So let's look at this, how this has been designed, or why is it done that way? Okay. You able to see a whiteboard now?
Yes.
Okay, great. So I was talking about responsibilities and I spoke about CRUD responsibilities in MVC, and we see that all these 4 different responsibilities are residing in the same class. Let's hypothetically think that we divided this responsibilities, or Microsoft divided these responsibilities for us in the scaffolded diagram and said, hey, you know what, create has to be separate, read has to be separate, update has to be separate, and delete has to be separate. Then, if we went on creating controllers, our controllers would look like this. It would be create, action, and now I would have created students controller, and then comes teachers, then the class, then institute, and goes on. If I keep adding controllers, and each has got hundreds of controllers, let's assume actions, now create is going to grow exponentially or in an increasing order. Similarly, we'll end up having for read. Now here it will be get student, corresponding options to what we have written a while ago. So, and the same story continues. And this can happen, same thing for update and delete as well. Right? So it could happen just the same way we discussed. Here is student, here is student, and so and so. Now, what we are seeing here is we are seeing this as a responsibility at a resource level, right? Agree? So when I showed this code, we have one resource which is called as student, and responsibilities for a student is that a student can be created, student can be added, a student can be deleted, and so and so. But this is not engraved on stone. When you see that this is too much of responsibility to handle, you could actually break this down and take it forward. So the decision making is still with we, the intellectual people, to make a decision based on the knowledge of the domain and what we want to keep it together, what is too much to handle. It's like if it's too hot potato in your mouth, spit it out and see what to do with it, just rather than dealing with it and keeping it there. So that's on the decision making. So there might be cases where you can see that, oh, hey, this is different responsibility. Why is it here? It means that there is another decision rationale to keep it. Maybe all object and the functions has to be close together. Some the principle might have been applied, or some logical grouping like this might have been the right one, telling that, okay, this is the responsibility and this is the best way to handle responsibility in this case. Yeah, so now we quickly move on to a couple of more examples to see how responsibilities can be identified and segregated. So here is another simple example that I pulled out from net. So I see that there is an invitation service which is doing a simple behavior, send invite. Do the audience see my Visual Studio screen now?
Yes.
Yeah, great. So send invite is a simple function which takes 3 parameters, email, first name and last name, sends out email using SMTP client. And let's say we were doing this meetup webinar and we wanted to have our own software to do this, and we were designing this piece of code. At first, this looks like, okay, everything is related, but if you look at a little bit of zoom level, you realize that the first 2 validations are related to user, right? And the next is also related to user, but it is very specific about email, right? So if you have to decide that, okay, hey, you know what, this has got multiple reasons to change. If there is a validation change that is going to happen for first name, last name, then this will undergo change. If there is a validation change that is going to be different for email, then again this class is going to change. So then if you think that it is having different access, you could go ahead and refactor in a way that move that responsibility to separate class and call it as a username. Here you can have your user, which is very close to username service, and data and responsibilities of functions reside inside that. All right. So then similarly, you have email service who is responsible for validating the email services. Now, any changes to the code, it doesn't go and impact the actual invitation service. It happens in isolation inside email service. And with other concepts that we are going to discuss in the webinar, which you might have already be aware of, with dependency injection and other useful techniques and principles, we could actually test every item in isolation once we are in this shape. Now you could see that it's the same code, or which achieves the same functionality, now is changed in a drastic manner. So here is my send invite. Here is my invitation service, which is now changed in a way. Now I have created mechanism to inject these things by segregating the responsibility, telling that, okay, you know what, username service has to be separate because it may undergo changes for its own reasons. Email service might undergo changes for its own reasons. And send invite, which is going to consume this two validations, can be abstracted and said that even I just have to call this contract, and whatever changes happens, I'm not going to get affected, considering that this person has dealt with his responsibility in a clean fashion. So here is on the right hand side, you see the older one, which is having multiple responsibilities, and here is on the left hand side, you see same responsibilities given to individual classes and dealt in a different way. Right. So then let's go to another example of the same thing. Okay, so I'll close this. Close up this. All right, so now I've taken another example I've just created my own simple online recharge class. Let's say from tomorrow I want to create my own company which does online recharge just like Paytm started its journey, or FreeCharge does, right? So this is a simple recharge class. For now, it looks like self-sufficient. It has got phone number, it has got amount, balance amount, provider name, and recharge function, which takes necessary parameters, phone number and provider. Maybe I missed that parameter, and amount, how much amount it has to recharge. Now here is a simple logic that says that if provider is this, then call that particular API, else call another API. It's simple for now with two providers, but now if it's too much for me, or if it's too many responsibilities in these classes, I can ask questions like, hey, you know what, this can change, this can change, or this can change, right? For example, we are dealing with India today, and we have a different phone number format. If we are to onboard other countries, then we might have to do some formatting of the phone number. If I have to validate a phone number telling that it has to be this format, then I would write a function here which says that, okay, check for the valid format. And it can grow and become complex when we want to do multiple checks for different regions. So this might look like a responsibility which might not change very often, but when there is a change that is going to happen, then we can think that, hey, this is a different access. Nothing has changed here, but maybe we have to look at the formatting to validate it. Similarly, when we add another provider here, we might have to come and say that, you know what, I just have to add one more responsibility here, which is dealing with a new provider. So there are multiple responsibilities, or this class may change for multiple requirements changes or multiple reasons. It will change if there is anything related to phone number, if it will change anything related to the way recharge amount is handled. Now it's data pack, it's tariff. Now this is going to change. It's not only about balance amount, it is about your data usage, how much GB is available. This is going to change. When there is a new provider, this is going to change. We have multiple accesses of it, but can we remove all this altogether? No. For me to have a recharge, I need to have all these objects available for me. So I choose to move the responsibilities to a different way and do like this. I say that, hey, you know, I want to have an abstract layer where every recharge client who is going to implement is going to accept it, and then my Airtel recharge is going to implement it. Similarly, my Vodafone recharge, and tomorrow maybe Geo or something else that comes up. And then my online SRP online recharge, in contrast with simple online recharge, will look like this, right? So all the data that belongs to respective objects has been moved to them, and it is kept lightweight. Now, if there is any change in the payment, the person who implements the payment is going to be responsible for all the data and operations there. Just that he is going to give necessary inputs or outputs to this class if it has to depend on payment. So now each and every individual responsibility is moved to its own class so that it can be dealt in there, it can be tested in isolation, it will have less impact on other parts of the system. Now, when there is a new provider, iRecharge will be implemented, and there may be a CTR here which will take iRecharge and it will assign to the recharge. Then I have its object available, and then I operate, either it's on Vodafone, Airtel, or whatever instance that is available for me. So that way, I have reduced changes that I make to this class, right? So it's telling that it's not accessible, that's not a problem. All right, that's not important anyway. So hope we got the crux of it. Right, so now the next important thing. I was having this a couple of years ago with a developer, similar session, and after the session, you mentioned, you mean to say that now I have to go back and break down the class, every method in the class into a separate class because it's separate responsibility, or what should I do? So knowing when to stop is going back to the fundamentals. Think of object-oriented principles, which says that the data and the functions related, the cohesive methods has to be encapsulated in a particular way. So you don't have to break it to very, very granular level and keep everything separated. So that's the decision rationale you're going to take. It might be operation, it might be responsibilities. There might be two responsibilities be there and still be okay because there is not too much complexity yet. Don't be future speculative also. Don't think everything in that can happen in future today and make provision for it. So don't be future speculative, create lot classes upfront, a lot of interfaces upfront. Whenever there is an instance, then take that decision when it's not too late. So my rule is fool me once, shame on you, fool me twice, shame on me. First time I missed out to identify the responsibility, that's okay. It's fine. So next time when I come and say that, okay, I'm adding another responsibility to existing responsibilities, then it's shame on me. I'm getting fooled again and again. I'm going and making changes to the same responsibilities. Right. So quick summary on what we discussed so far. Classes with distinct responsibilities result in more flexible design. It's easy to maintain, it's easy to test, and it's less fragile. Changes made to one class can be isolated and tested in a particular class by not impacting the other parts of the application, which is otherwise is going to be really difficult if it's a spaghetti code, right? When we are actually speaking about single principles, we also touched upon open, closed, and interface segregation principles. That's the best part I have noticed working with solid principles or refactoring to solid principles, because you start with one, you end up having provisions for other principles as well, or you end up touching the other principles for creating provision for dependency injection by having smaller segregated interfaces, and you see that this function is getting frequently changed. So is it open close? Should I be extending it? And so on. So yep. So I think we are doing good on the time. We planned it for 30 40 minutes. So yes, with great power comes great responsibilities, but I say that with solid knowledge comes superpowers for any software developer.